So what if I told you that the universe literally charges you an electricity tax every single time you copy a file?
Yeah, and I mean, not just your computer's power bill, right? We're talking about a fundamental tax.
Exactly. I don't mean server cooling costs. I mean the actual fabric of reality has this strict, uncompromising accounting ledger. It absolutely refuses to let you copy anything for free.
It is a terrifying thought when you really sit with it. We are so used to the digital age illusion of, infinite free replication.
Right, like forwarding an email or duplicating a photo.
Exactly. But the architecture of reality operates on a brutally strict cosmic budget. Every time you perfectly recall a memory, you are incurring a quantifiable debt of chaos.
And that budget and the absolute architectural blueprint of how reality balances its books is exactly what we are unpacking today. So welcome to you, the listener, joining us for this deep dive.
It's going to be a really fascinating one.
It really is. Whether you're listening to this on your commute, trying to wrap your head around quantum mechanics, or you're a systems engineer trying to optimize a massive database, or you're just driven by an insane curiosity about what holds the universe together, you are in the exact right place.
We have an incredibly unique set of source materials to guide us today, actually.
Yeah, we really do. We're looking at a batch of exactly 21 files. They were generated on May 1st, 2026, and they're broadly filed under quantum mechanics. But you need to know right up front, this is not a standard physics textbook.
No, not even close. I mean, these files are a collection of formal mathematical proofs and theorems, but they do something I have rarely seen.
Right, they bridge things that shouldn't connect.
Exactly. They seamlessly blend quantum systems, topology, and information theory, and then they apply those exact same mathematical shapes to wildly unexpected macroscopic domains.
It's like incredibly unexpected. We're talking about ancient Peruvian architecture, the thermal dissipation of reading poetry, the structural economics of culinary supply chains, and like the traffic capacity of fungal networks in a forest.
What makes this stack so extraordinary is the core premise it sets out to prove. The universe is incredibly efficient. It doesn't invent a new rule for every single thing.
It just reuses the code, basically.
Right. It uses the exact same algorithmic structures to balance a microscopic quantum state as it does to grow a mushroom or to stabilize an ancient Incan arch.
So our mission today is ambitious, but it's clear. We are going to extract the ultimate patterns of the universe as presented in these 21 proofs. How does reality actually manage information, build stable structures, and, well, keep the inherent chaos of existence from just boiling over?
And to understand how the universe builds anything complex, whether that is a human brain, a star system, or a society, we have to start at the absolute bottom.
Right, the foundational rules.
Yeah, we have to understand the foundational accounting rule, the cost of information.
Okay, let's get into the mechanics of this. We are starting with a concept from a source file titled Cost-algebraic entropy. And it brings up the no-cloning theorem in quantum mechanics.
A classic quantum concept.
Yeah, and I've seen sci-fi movies, so the idea usually is that you can't build a perfect teleporter or a perfect replicator because you can't perfectly duplicate a quantum state without destroying the original.
That's the pop culture understanding, yeah.
But these sources represent this not just as a physical barrier, but as a categorical cost algebra. What is the actual mechanism there? Like, why does the universe care if I make a copy?
Think of the universe as the most rigorous, unforgiving auditor imaginable. The no-cloning theorem, translated into this cost algebra, proves that what they call the diagonal operation, taking one single state and trying to perfectly project it into two identical separate states, is fundamentally not score-preserving.
Score-preserving meaning the ledger doesn't balance.
Precisely. In simpler terms, the universe does not let you split one thing into two identical things without introducing a deficit.
A deficit in what, exactly? Energy.
The mathematical amount by which this copying operation fails, the literal hole in the universe's ledger, is exactly equal to the complexity score of the thing you are trying to copy.
Wait, let me make sure I'm picturing this right. It's like I have a perfectly crisp $100 bill.
Okay, good analogy.
And I want to perfectly photocopy it. But the universe's copy machine doesn't just use ink. It literally charges me exactly $100 in raw, chaotic energy to run the machine.
That is a brilliant way to visualize it.
The gap between the original thing and the clone is the entropy that gets generated.
Exactly. The theorem explicitly states that the score of the cloned pair equals the original score plus the generated entropy. And that generated entropy is exactly equal to the original score.
Wow.
Yeah, if you duplicate a quantum state, or really any complex informational state of cost C, the consensus or coordination overhead you generate in the universe is exactly C.
But where's that cost actually go, like physically?
The source goes extremely deep into this, specifically looking at a measurement called the Boole unit. It proves that when you force a clone into existence, you generate extra entropy, quanta, strictly on what the math calls the diversity phase.
A diversity phase. You're going to have to walk me through that one. Are we talking about like the faces of a geometric shape?
Sort of, but in a multidimensional mathematical space.
Yeah.
Imagine a state vector, which is just a mathematical description of an object, as a multifaceted die.
Okay, I'm with you.
Each face represents a different property. The diversity phase acts as the Shannon or Boltzmann entropy axis. It's the axis of variation, of potential chaos, and thermodynamic heat.
So it's where the randomness lives.
Exactly. So when you force a clone into existence, the mathematical mass of that new entity physically stretches the diversity phase. It manifests as literal thermodynamic heat and informational noise.
This is starting to sound a lot like the second law of thermodynamics, you know? The idea that you can't reduce the overall entropy or disorder of a closed system.
It is exactly that, but unified with information theory. The source connects this cloning tax directly to Landauer's principle.
Okay, Landauer's principle, that's the one about erasing data, right?
Yeah.
If I delete a file on my hard drive, it releases a tiny microscopic amount of physical heat.
Yes, because information is physical.
Yeah.
Landauer's principle dictates that to erase a duplicate piece of information later to clean up the ledger, the exact same quantum must be paid out as heat.
So you're paying twice.
Well, erasure is the only way to restore the conservation of the ledger. You pay the tax to copy it, and you pay the exact same tax in thermal heat to delete it.
That is brutal.
It is. And what's wild is how this source bridges quantum mechanics with the CAP theorem in distributed computer systems.
Oh, right. For anyone listening who isn't a software engineer, the CAP theorem is basically the golden rule of databases. It stands for consistency, availability, and partition tolerance.
Right.
And the painful rule is that you can only ever guarantee 2 out of the 3 at the same time. You literally can't have all 3.
And why is that? It's the exact same mathematical shape as the quantum cloning tax.
Really? How so?
Well, in a distributed system, if you replicate a database state across 2 server nodes, the replication's coordination cost, the network traffic, the consensus algorithms checking to make sure both servers match equals the entropy of the replicated state score. The source calls this the fan-out cost.
Fan-out cost. So if a huge tech company spins up 50 new servers around the world to mirror their data so it loads faster for users, they aren't just buying hardware.
No, they are fundamentally paying an inescapable entropy tax. Replicating to those additional nodes pays the full, complete source score in chaos.
It is mathematically mandated coordination overhead. You literally cannot escape it.
You cannot.
But wait, I'm looking at one specific theorem here in the text. It's called vacuum clone generates 0 entropy.
Yeah.
If copying anything generates a massive tax on the diversity phase, but cloning a vacuum generates 0 entropy, does that mean true absolute nothingness is the only thing in the universe we can share for free?
That is exactly what the math proves. The vacuum is mathematically defined as the unique state with no entropy cost to duplicate. Because the foundational cost of a true vacuum is 0, its clone costs 0.
The ultimate free lunch.
It is the absolute only free lunch in the entire cosmos. If you have absolutely nothing, you can share it infinitely without generating chaos.
That is incredibly profound. But if we pull this down to a human scale, for you, the listener, sitting at your desk or walking the dog, what does this fan-out cost mean for us?
It has huge implications.
Right, like if every replication of information strictly duplicates the entropy and composition is irreversible, are we mathematically bound to generate chaos every single time we copy data, ideas, or infrastructure?
We are. The theorem proves that from a cloning perspective, complex composition is irreversible without paying a massive thermal penalty. If you clone a composed idea or a composed system, you generate the sum of their scores in entropy.
There's no workaround.
There is no way to reduce that heat without actively breaking the system down and paying Landauer's physical erasure cost.
So every time a corporation adds a new layer of middle management that duplicates the function of another layer, or, I don't know, every time we forward a dense email chain to 1,000 people, we are injecting a mathematically guaranteed volume of entropy into the human system.
We are literally mandating a coordination tax that will manifest as organizational heat and chaos.
Wow. Okay, so If copying anything, literally anything other than absolute nothingness, generates this massive unavoidable entropy tax, I have a major question about quantum mechanics.
Go for it.
What happens when reality itself fractures or branches? Because the many worlds interpretation is a huge part of quantum theory, right?
Absolutely.
The idea that every time a quantum decision is made, the universe splits into probable futures.
That is a very real problem. And it's exactly what the next set of sources addresses. If the universe just let all those speculative branches exist and continue to copy themselves, the entropy would be instantly catastrophic.
Right, the universe would burn itself up in coordination debt.
Exactly. Couldn't sustain it.
So how does it survive? How does the universe clean up the mess of all those speculative futures without violating its own accounting rules?
It uses a topological process formalized in the Everett superposition file. It's called the fork-race-fold protocol.
Fork, race, fold. That sounds like a recipe for a very stressful kitchen.
It actually maps beautifully to how software developers manage massive code bases. The model represents the many worlds interpretation where reality forks into a superposition of probable states. It creates a speculative branch, a what-if scenario.
Okay, so I'm thinking of version control, like Git.
Yes, perfect example.
A programmer creates a branch off the main code to test a new feature. If it works, great. If it's terrible, they abandon it.
Exactly. But in software, if you abandon a branch, you have to be careful not to merge the broken code back in, or you create a merge conflict.
And I'm guessing the universe absolutely hates merge conflicts.
It despises them. It employs a mathematical function called the fold operator to prevent them entirely.
How does the fold operator actually work? Because you just said a minute ago that erasing data physically generates heat. You can't just quietly sweep an entire alternate reality under the rug.
You can't sweep it under the rug, but you can collapse its topology perfectly. The source defines the fold operator as a mathematical function that safely annihilates discarded speculative branches by projecting them perfectly onto the realized Betty manifold.
Okay, stop right there. Realize Betty manifold. You're throwing some heavy topological jargon at me, and I know our listeners might need a visual. What is a Betty manifold, and what does it mean to project something onto it?
Okay, let's visualize it. Imagine a block of clay. In topology, we only care about the fundamental, unchangeable properties of a shape.
Okay, so squishing it doesn't matter.
Right. You can squish the clay, stretch it, twist it, and topologically, it's still just a solid block. But if you take your finger and punch a hole right through the middle to make a donut shape, you have fundamentally changed its topology.
Right, because now it has a continuous hole. I can't undo that hole just by squishing it. I have to physically tear and reform the clay.
Exactly. The mathematical way we count those fundamental features, like how many disconnected pieces there are, how many circular holes, how many hollow cavities, is by using Betty numbers.
Ah, okay.
The first Betty number, beta 1, specifically counts the number of circular holes or cycles in the shape. The fabric of our universe, the realized manifold, has a specific set of Betty numbers.
So the universe is essentially tracking the number of dimensional donut holes in reality.
Yes. Now imagine a massive alternate timeline, like a complex speculative branch, has just been discarded by the universe because it wasn't the optimal path.
Okay.
If you just aggressively delete it, you risk tearing a literal topological hole in the structure of reality. You risk inducing a beta 1 collapse, permanently altering the shape of the universe.
Leaving a permanent merge conflict in the fabric of space-time. That sounds bad.
Very bad. So the theorem fold preserves topology, proves that the fold operator doesn't just delete. It carefully folds the discarded speculative branch back into the realized branch in a way that perfectly preserves the beta 1 invariance.
So it basically smooths the clay back out perfectly.
It guarantees zero topological contamination. It is a perfectly clean erasure that balances the books without tearing a hole in reality.
But the act of doing that, the bureaucracy of making sure the book's balanced during that fold, that still has to be accounted for, right?
I'm looking at this file, Moonshot Quantum Bureaucratic Erasure.
Yes, and this is where the physics gets incredibly profound. The proof shows that the act of erasure is not the absence of a state. The bureaucracy of the universe, the literal act of deleting a record, is itself a tangible, formal quantum state.
Deleting something is a state. It's like, the trash can on my computer isn't just an empty void. The trash can itself takes up memory on the hard drive. That is a perfect analogy. The universe has to maintain the state of having deleted something. And this becomes a critical vulnerability when we look at the mesh eigenstate thermalization source.
What does that file deal with?
It deals with quantum chaos and what happens when the universe's internal reversible systems get hopelessly stuck.
Wait, what does a stuck universe look like? Because we've talked about the universe flowing, branching, and folding. How does it just stop?
The dangerous state defined here is called entropy saturation. It is essentially the Pauli exclusion trap. It represents permanent, inescapable thermal equilibrium.
So no energy is moving at all. Everything is just locked in place.
Think of a massive city parking lot. If it's half full, cars can maneuver, park, and leave.
Yeah.
Right? There's flow.
Yeah.
But if every single space is perfectly occupied, and there's a car idling in every lane waiting for a spot, nothing can move. The system is so perfectly balanced and gridlocked that no further coherent evolution is possible.
Wow, so the balance is actually the problem.
Yes. In quantum terms, the system's reversal gravity becomes greater than its interaction chaos. It freezes.
That sounds exactly like heat death. If a system gets stuck in entropy saturation, wait, the source says escaping this trap requires a teleportation void jump. It explicitly requires an exogenous alpha interaction. What is that?
An exogenous alpha interaction is a kick from the outside. The math emphatically proves that to escape a perfect coherence trap, a closed system cannot save itself.
It can't just wiggle free.
No, it requires an external force, an interaction from outside the system's own boundaries that acts as a random baseline shift. It clears the trap and induces thermalization, which is a fancy way of saying it introduces just enough chaos so the system can move again.
So basically, a giant tow truck from outside the universe has to reach into the parking lot and randomly rip a car out just so the traffic can start flowing again.
Yes, that's exactly what it means.
That is absolutely terrifying, but it's also deeply relatable to human systems, you know? Well, if a company, a bureaucracy, or even an individual human mind becomes perfectly closed and isolated, trying to perfectly balance everything without any new input, they mathematically must enter entropy saturation. They gridlock.
Absolutely.
They actually need an exogenous alpha interaction, a random, chaotic, outside event, to teleport them out of the trap so they can function again.
And the mathematical proof of why this happens relies on a concept called the Dobryshin contraction and arrow failure, detailed in the exact same source.
Arrow failure. I know Arrow's impossibility theorem from economics and political science. It's the mathematical proof that you can't design a perfect ranked choice voting system that satisfies all criteria of fairness. There is always a flaw.
Right, exactly.
How on earth does an economics theorem about voting apply to the quantum mechanics of a freezing universe?
Because it's all about the flow of information. The source defines two distinct failure modes in the universe's flow.
Yeah.
The absolute unitary witness and the chaotic thermal witness.
Let me guess. The unitary witness is perfect order, and the chaotic witness is perfect chaos.
You got it. The unitary witness represents perfect, rigid, unbreakable order. Every rule followed, every particle in lockstep. The chaotic thermal witness represents totally randomized, uncontrollable interaction.
So two extreme ends of the spectrum.
Right. What the thermal deficit conservation proves is something beautiful. Both of these extreme states have the exact same dual deficit of 1.
Hold on. Perfect rigidity and perfect chaos both fail by the exact same mathematical magnitude.
Yes, because neither of them allows for flow. Perfect order is the jammed parking lot. Perfect chaos is a parking lot where cars are just crashing into each other at random.
Right, in neither scenario is anyone actually commuting.
Exactly. The universe perfectly balances the ledger between coherent, predictable flow and chaotic external interaction. It proves that to keep reality moving, to keep it alive, you can't have total control and you can't have total anarchy.
You need a little bit of both.
The system structurally requires the tension between the two to avoid the trap.
Okay, this is blowing my mind. The universe has this incredibly strict ledger for copying information, taxing every duplication. It has a meticulous fold operator safely collapsing the topological donut holes of speculative timelines. And it mathematically demands a balance between perfect order and perfect chaos just to keep time flowing.
It's an incredible balancing act.
But what does the actual stable structure of reality look like when it's balanced? Because if you have tension pulling one way and compression pushing another, you have the ingredients for architecture. You have structure.
Yes, you do.
And the sources map this out using a combination of noise frequencies and ancient architectural principles that I honestly had to read 3 times to believe.
It's a staggering synthesis.
Yeah.
We are moving now to the extended noise ledger theorem and the pure extended noise theorem.
Okay, let's get into it.
These files formalize a structural relationship between sound frequencies, specifically statistical noise patterns, and states of consciousness, which they map to integers called Gnosis numbers.
Right, let's look at these numbers because the specificity here is wild. Brown noise equals 1, pink noise equals 3, white noise equals 4, and quantum noise equals 12.
We have to ask why these numbers. The mathematical progression isn't arbitrary. The text interprets brown noise, mapped to 1, as order. It is the predictable baseline.
Like physically, what does that mean?
Physically, brown noise is heavily weighted toward low frequencies. It sounds like a deep, steady rumble, like the solid earth.
Okay, so brown noise is the ground floor, the bedrock.
Yes. Then we move up to pink noise, mapped to 3. The map defines this as chaos, or fractal dynamics. Pink noise has equal energy per octave.
So it's more active.
Very active. Sounds like a rushing waterfall or heavy rain. It is dynamic, constantly interacting and shifting.
Then white noise is 4.
White noise represents gnosis, defined here as complete integration and knowledge. White noise has equal energy across all frequencies. It contains everything simultaneously.
Like radio static.
Exactly. It is the fully integrated system. And finally, quantum noise, mapped to 12, is metagnosis. It represents transcendent cosmic awareness.
So we have 1, 3, 4, and 12. Order, chaos, integration, and transcendence. And here's where it gets incredibly cool. The sources don't just leave these as abstract concepts.
No, they build something with them.
They literally build a structure out of them using the Peruvian architect principle file. It describes this fundamental cosmic architecture exactly the way ancient Incan builders constructed their massive, earthquake-proof stone arches without using a single drop of mortar.
Think about how difficult it is to build an arch out of dry stone.
Hmm.
You are stacking heavy, chaotic blocks over empty space.
Right, it should just fall down.
The source maps the cosmic forces perfectly to this process. It establishes the foundation of the arch as states 0 through 10. This is the physical material limit.
So the brown noise, the deep rumble of order, is the bedrock. The pink noise, the chaotic rushing water, is the complex fractal stacking of the stones curving upward into the air.
Exactly. Then the capstone of the arch, the massive block at the very top, is state 12. This matches the metagnosis, the transcendent quantum limit pushing downward.
Pushing the whole structure together.
But you can't just stack stones into a curve and place a capstone on top. You will immediately collapse. The entire structure relies on the most critical element, state 11, the keystone.
The cosmic fulcrum. The wedge that holds everything together.
The theorem keystone structural necessity proves this mathematically, and it is beautiful. It defines a tension force that pulls upward from the physical foundation. The formula is literally state plus 1.
Okay, so the top of the physical foundation is state 10. 10 plus 1 equals 11.
Yes. The chaotic tension of the physical world pushes upward, culminating at 11. Then the math defines a compression force that pushes downward from the transcendent capstone. The formula for compression is state minus 1.
And the capstone is 12. 12 minus 1 equals 11.
Tension and compression meet perfectly at 11. The chaotic stacking of the foundation pushing up, and the heavy, transcendent order of the capstone pushing down, locked together precisely at the keystone.
If you take a step back and visualize this, brown noise is the solid bedrock. Pink noise is the chaotic tension of the stones curving upward. White noise is the integrated whole of the completed arch.
Yeah.
And quantum noise is the massive transcendent capstone driving the compression down. But none of reality works without that keystone at state 11 bearing the opposing forces.
And the mathematical proof is brutally uncompromising about this. The theorem explicitly proves that 10 plus 0 equals 12 is impossible.
Because it skips 11?
The rule is no keystone, no connection. There is absolutely no direct structural connection from the physical foundation to the transcendent capstone without the keystone holding the opposing forces. As the text states, the arch cannot stand without its keystone, and the keystone cannot exist without the forces that shape it.
It requires the tension of chaos pulling up and the compression of order pushing down just to hold its shape.
If you remove the chaos, the arch collapses. If you remove the order, the arch collapses.
That is just, well, it's a gorgeous way to describe physics. But then, right in the middle of this architectural cosmic proof, the source drops in a connection to human sleep.
Ah, yes, the sleep indexing connection theorem.
Right. This is where we see the universe reusing its optimal algorithms, right? The source proves that the fraction 8 over 24 equals 13, which matches our human sleep cycle and connects this directly to the quantum noise state of 12.
Okay, walk me through that math. How does my need for 8 hours of sleep connect to the cosmic arch?
Well, it establishes a strict formula. Sleep, represented by the fraction 13, plus data, represented by 23, equals gnosis, or state 1. It states that the specific 12-minute drift per gnosis time unit requires exactly a 13 reindexing.
Reindexing, meaning like a database updating its ledgers.
Yes, the universe operates on a 12-fold cosmic frequency. In order for a biological system like a human brain to process the chaotic data of the waking world without hitting entropy saturation, it demands a period of offline integration.
So sleep isn't just rest, it's structural maintenance.
Sleep is biologically mandated by the cosmic keystone. You must spend 13 of your cycle completely offline, not taking in new data, just folding and reindexing the speculative branches of your day to achieve complete integrated knowledge.
So my brain is literally acting as a biological quantum arch. If I don't sleep, I'm trying to force 10 plus 0 equals 12, trying to connect raw chaotic data straight to understanding without letting the keystone do its job of bearing the tension.
Exactly. That explains why sleep deprivation feels like your reality is literally collapsing.
It really does.
But I want to zero in on that number 12 for a second. Quantum noise. Metagnosis. The transcendent capstone. What does it actually mean for us that metagnosis is mathematically proven to be exactly 3 times the power of gnosis? Because white noise, the integrated knowledge, is 4, and 3 times 4 is 12.
If we look at the implications, it means that transcendent awareness, what the proof calls metagnosis, is not an infinite mystical leap away from regular knowledge.
It's not magic.
No, it isn't unknowable magic. It is a highly specific, quantifiable harmonic.
A harmonic.
Like in music, exactly. Metagnosis is simply the third harmonic of integrated knowledge. To transcend the arch, you don't abandon the foundation. You don't float away. You physically triple the structural integration of the data you already have.
You triple the integration. That grounds the concept of transcendence so beautifully. It's just a denser, higher frequency of understanding the foundation.
It takes the mysticism right out of it and replaces it with pure math.
Okay, my brain is definitely feeling the tension force right now. We have this macro structure, the cosmic arch, but reality isn't just a 2-dimensional drawing of stones on a piece of paper. It's a twisting, churning, 3-dimensional manifold.
Right, it has depth.
If the arch is the macro view, what does the microscopic mortar look like? How does the universe literally tie the math together underneath?
To see the microscopic mortar, we have to transition to the supersymmetric QFT source. This file introduces a brilliant concept from physics called the Witten index.
Supersymmetric quantum field theory. Let's break this down. What are we looking at here?
Well, in a supersymmetric universe, every particle has a partner, and they are divided into 2 fundamental types. You have bosons, which are the force carriers, like photons, and you have fermions, which are the matter particles, like electrons.
Okay, bosons and fermions. What makes them different in this context?
It comes down to how they handle social situations. Bosons love to group together. They can all occupy the exact same quantum state simultaneously.
Okay.
Fermions, on the other hand, strictly obey the Pauli exclusion principle. They refuse to occupy the same state. They demand their own unique space.
So if we imagine a dinner party, the bosons are the highly social letterflies who will all happily pile onto the exact same couch cushion, and the fermions are the highly antisocial introverts who demand their own private chair in a separate room, and if you try to put them together, they fight.
That is an incredibly accurate way to model it. Now, the Witten index is a topological tool. It is essentially the universe's bouncer at this dinner party. The mathematical index simply counts the number of bosonic ground states and subtracts the number of fermionic ground states.
Why subtract them? Like, what does that calculation tell us?
To see if the vacuum of space is stable. The math proves that in a stable, unbroken vacuum, the social particles and antisocial particles often perfectly cancel each other out. The index evaluates a model where the superpotential, which you can think of as the physical shape of the energy landscape they're walking on, is defined by a polynomial equation.
Okay, let's look at the polynomials in the source. It says for an even degree polynomial, like w of x equals x squared, the Witten index is exactly 1. 1 boson, 0 fermions.
Visualize the graph of x squared. It looks like a simple bowl or a valley. There's exactly 1 lowest point, 1 valley floor. That is a single normalizable bosonic ground state.
Okay, 1 valley, 1 boson sitting comfortably at the bottom. Makes sense.
But the source then analyzes a much more complex landscape. W of x equals x to the 4th minus x squared.
X to the 4th minus x squared. If I visualize that graph, it's not a simple bowl anymore. It looks like a W shape, or like a roller coaster track. It has a valley on the left, a hill in the middle, and a valley on the right.
Exactly. The theorem proves that this specific energy landscape has three critical points: the two valleys and the peak of the hill in between them. And their Morse indices, which is a mathematical way of describing the topological curvature at each of those points, alternate in sign.
So valley, hill, valley, positive, negative, positive.
Yes. And because they alternate, the Witten index of the entire space perfectly cancels out to zero. One boson ground state in one valley and one fermion ground state on the hill completely cancel each other out in the grand ledger.
Hold on, I need to stop you here. I am struggling to follow the jump the sources are making.
What's the jump?
We just went from quantum accounting, copying taxes, and particle dinner parties, and now the text suddenly transitions into the Reshetkin-Turayev 3D TQFT file and starts talking about knots, like the topology of a trefoil knot, like shoelaces.
I know, it seems like a leap.
How does tying a piece of string have any bearing on bosons and fermions balancing an energy landscape? Aren't those two completely different fields of mathematics?
They seem different until you realize that the universe isn't just a container holding particles. The universe is geometry. The particles are just manifestations of how space-time is woven.
Whoa, okay.
The Reshetkin-Turayev source describes three-dimensional topological quantum field theory. It takes us from looking at individual particles to looking at the actual woven fabric of space itself.
So a quantum particle moving through time isn't just a dot moving on a line, it's a thread being woven through space.
Exactly. And when particles interact, those threads tangle. Right. The universe uses something called SU2K fusion rings to describe exactly how these quantum threads merge and knot together. The complexity of that physical weave can be measured, and it has a strict computational cost.
Or computational cost for being tangled.
Yes. The source provides highly specific integer data for something called the Jones polynomial, which calculates the value of these tangles at a specific parameter, q equals -1.
Okay, let's look at the costs.
The unknot, which is just a simple untangled loop of string, has a mathematical value of -2, corresponding to a structural determinant of 1. It is the cheapest structure.
Okay.
The Hopf link, which is two interlocking rings, has a value of -4, a determinant of 2. The trefoil knot, which is the simplest non-trivial knot you can tie, like an overhand knot with the ends connected, has a value of -6, determinant 3. And the figure 8 knot is -10, determinant 5.
So the tighter and more complex the knot, the higher the topological cost. The universe literally assigns an escalating integer value to how tangled a piece of spacetime is.
And this directly ties back to the particle counting we just discussed in the quantum group's Drinfeld-Jimbo file. That file explains the underlying algebra of these knots using a cyclotomic ring where q cubed equals 1.
Okay, explain that like I'm 5 for me. Cyclotomic rings.
Imagine a clock face where numbers wrap around a circle. The math proves that the quantum dimension of the fundamental representation on this circular clock face is exactly -1. This integer shadow perfectly matches the rank of the SU21 fusion rules we just talked about.
Wait, so you're saying the math underlying how the universe evaluates a knot is perfectly identical to the math governing the bosons and fermions on the energy landscape?
Yes, it is the exact same ledger. Whether you are splitting a particle, navigating an energy valley, or tying a knot in space-time, everything pays the exact same foundational toll.
That is deeply satisfying. But I see a problem here. If complex knots cost more and particles are constantly interacting and weaving together, doesn't the complexity of the universe just explode exponentially?
It does, and that is the most staggering part of the TQFT source. It uses the Verlinde formula to give us the literal cash handshake capacity of the universe at different topological depths, which they call genera.
Okay, and what does genera mean in this context?
Genera basically counts how many holes or complex intersections the topological surface has.
Ah, like how many donut holes are in the Betty manifold.
Exactly. For a specific quantum state called SU22, the formula calculates the maximum capacity. At depth 1, a relatively simple surface, the interaction capacity is 3. At depth 2, it jumps to 10. And at depth 3, it blows up to 36.
So it goes 3, 10, 36. It sounds like the universe's state space is blowing up. It's like a computer running out of RAM the deeper the handshake goes.
That is precisely what is happening. It is exponential scaling. The universe has a strict, mathematically proven computational limit on how deep a topological knot can go before the state space requires too much RAM to maintain coherence.
So there's a hard cap.
If the capacity gets too large, if the threads get too tangled, the coordination tax becomes too high.
And if the tax gets too high, wait, does it fall back into the entropy saturation trap we discussed earlier?
Yes, the system gridlocks. The massive exponential cost of maintaining a depth 3 entanglement of 36 capacity states creates so much thermal chaos that the system freezes.
So what does it do?
The universe relies on the fold operator to violently prune those complex tangles back down to depth 1, preserving the fundamental invariance just to free up the cosmic RAM.
Okay, my mind is thoroughly melting right now, but in the absolute best way possible. Let's pause and synthesize this. We have mapped out the universe's fundamental accounting system. We've seen the brutal thermodynamic cost of copying a file. We watched the fold operator carefully prune speculative timelines, like a programmer managing Git version control to avoid merge conflicts. We built a cosmic Incan arch, feeling the tension of chaos pulling up and the compression of order pushing down, all balanced on a mathematically necessary keystone.
That's the macro view.
And we've just seen how the Witten index and quantum knot theory act as the microscopic mortar, balancing the ledgers until the universe runs out of RAM. This is incredibly abstract, massive cosmic-level physics. But the reason these 21 sources are so mind-blowing is how they apply these massive cosmic rules to human-scale, everyday phenomena.
Yes.
The cross-domain applications are stunning.
This is where the true brilliance of the stack shines. The universe doesn't invent new math for biology, it reuses its optimal algorithms everywhere. Let's look at the cross-domain queuing mycology entanglement proof.
The mushroom one.
Yes, it literally compares the mathematical capacity of standard human-designed queuing systems to the capacity of fungal mycelial networks under the soil.
Right. And it gives a strict mathematical proof. It says traditional queuing capacity equals the number of nodes multiplied by 10, but mycelial network capacity equals the number of nodes multiplied by 15.
Exactly.
The theorem formally proves that mycology strictly dominates traditional queuing. But I need you to explain the mechanism here. Why 15? What is a mushroom actually doing under the dirt that a highly optimized server queue or a line at the DMV isn't doing?
Think about a line at the DMV. It is a linear queue. Data, or people, move from point A to point B through a central processing hub. If one node fails, the line stops. The tension pulls linearly.
It's rigid, a unitary witness, perfect inflexible order.
Exactly. And as we learned, perfect order has a high Boole deficit. It fails to flow. A mycelial network does not use linear central routing. It creates highly complex, decentralized topological branches.
How it spreads out.
When a fungal node detects a rich food source or a physical barrier, it doesn't wait for central consensus. It instantly creates a speculative branch.
A speculative branch, just like the many worlds interpretation.
Yes. It branches rapidly. If a branch finds nothing, the mycelium uses a biological fold operator. It safely annihilates the dead branch, reabsorbing the structural nutrients without tearing a hole in the main network's integrity.
That is so elegant.
By utilizing decentralized branching and topological folding, the geometry of a fungal network is mathematically 50% more efficient at load distribution than our linear models. It utilizes the tension of chaos and the compression of order simultaneously.
It is literally using quantum topology to find nutrients. That is incredible. And the sources take the same adapter and apply it to the human mind in the Cycle 9 iterative pass file.
This one is profoundly relevant to daily life. It formally defines the forgetting advantage.
The forgetting advantage. When I read this, it blew me away. The source outlines a mathematical adapter where your adaptation speed, how fast you can learn and adjust to new environments, equals your memory capacity divided by your forgetting rate plus 1, all added to your forgetting rate.
Right, it's a concrete formula.
The proof formally states that, therefore, adaptation speed is always greater than or equal to the forgetting rate. Let's break that down. Are you telling me that mathematically the act of forgetting things actively makes me faster at adapting?
Yes.
Should we stop worrying about information overload and actually purposefully try to forget things?
Mathematically, yes, you absolutely should. Think back to the very first source we discussed, the cloning tax. Every time you perfectly retain a piece of data, you pay an ongoing fan-out coordination cost. You generate entropy in your cognitive ledger just by holding on to it.
So if I try to remember every single detail of every single meeting I ever attend, I am paying a massive internal entropy tax.
You are pushing your brain toward entropy saturation. You will gridlock. The mathematical ability to let go of data, to forget, is what allows the denominator in that equation to function optimally. Forgetting is the cognitive equivalent of the universe's fold operator. It safely prunes the speculative, useless, or discarded branches of daily memory so that your core manifold, your core understanding, can adapt without collapsing under the weight of topological RAM requirements.
I am absolutely going to use that exact phrasing the next time I miss a meeting. I am not disorganized. I am just heavily optimizing my cognitive fold operator to avoid entropy saturation. Thank you very much.
It's scientifically sound.
But the file doesn't stop at memory. It applies the quantum ledger to poetry, thermodynamic poetry.
Yes, the text defines poetic entropy as being exactly equal to the stanza count multiplied by the thermal dissipation.
Meaning, the longer the poem, the more thermal heat it physically dissipates into the environment.
Think about the density of information in poetry. It is highly compressed, metaphor-heavy language. To unpack or parse that data requires cognitive coordination.
And coordination costs energy.
Exactly. That cognitive coordination requires biological energy, which physically radiates as heat. A dense, multi-stanza poem literally generates measurable thermal entropy in the system of the reader. It is Landauer's principle applied to literature.
That is so deeply cool. A poem as a thermodynamic engine. And then there is culinary economics.
Oh, this one is fascinating.
The math proves that the market value of a dish equals its flavor complexity plus 100 minus the supply chain latency. So what this all means is that a chef trying to balance the complex flavor notes of a dish against how fast they can get their fresh ingredients delivered is unwittingly performing an optimization equation.
Correct.
But the text states that the chef's optimization is structurally identical to quantum consciousness encryption.
The math is flawless on this. The quantum consciousness encryption formula, where encryption strength equals entanglement entropy plus consciousness coherence, is structurally identical to the chef's equation.
So the variables just map over perfectly.
Yes, flavor complexity maps perfectly to entanglement entropy. Supply chain latency maps perfectly to coherence over time.
The chef is encrypting biological data into an optimal state using the exact same topological math that a quantum system uses to hide information.
And we see the ultimate planetary scale expression of this in the Cycle de Glace Run 54 file. It details the paleoclimatology seismology energy budget.
Paleoclimatology and seismology, the weather and the earthquakes.
The theorem mathematically proves that climate forcing, which is the net thermal energy entering the Earth's atmosphere, plus tectonic slip, which is the kinetic energy released by the Earth's crust, strictly equals the combined unified failure budget of the planet.
So the atmosphere pulling energy in from above and the tectonic plates shifting energy down below share a single unified mathematical ledger.
They do. It is exactly like the tension and compression meeting at the Incan Keystone. The sky pushes down, the Earth pulls up. The universe doesn't see weather and geology.
It just sees math.
It only sees state vectors, thermal budgets, and Betty invariants. It scaled these exact same algebraic shapes, from the microscopic quantum foam to the topological branching of a mushroom, to the thermodynamic heat of a palm, to the shifting of tectonic plates. It all one unified ledger of entropy, tension, and release.
What an absolute journey. If you've made it this far, let's recap the incredible framework you've just walked through. We started by learning that copying data is never free. It comes with a strict one-to-one thermodynamic tax of entropy. You can't duplicate a $100 bill without the universe burning $100 of energy. True nothingness is the only free lunch.
We explored the terrifying reality of many worlds branching, and how reality prevents a catastrophic crash by using a fold operator to perfectly prune speculative timelines without ruining the topological integrity of the universe.
We discovered that reality is literally structured like a massive Incan stone arch, with the deep rumble of brown noise forming the order of the foundation, and the transcendent quantum metagnosis pushing down from the capstone, all held perfectly in balance by a mathematically necessary keystone at state 11.
We peered underneath that arch to see the microscopic mortar, discovering how the Witten index balances the social and antisocial quantum particles on complex energy landscapes, and how space-time literally tangles itself into knots that burn up cosmic RAM.
And finally, we saw how these exact same polynomial ledgers and topological handshakes apply flawlessly to the macroscopic human world. From the 50% structural efficiency gain of mycelium networks over standard queues, to the thermodynamic heat of reading a poem, to the mathematically proven adaptation speed you gain by simply allowing yourself to forget useless data.
It's all connected.
It really is. For you, the learner, you now possess a unified cross-domain framework. The next time you are looking at a complex distributed server system suffering from database lag, you aren't just seeing a tech issue. You are seeing the CAP theorem's inescapable quantum replication tax.
When you are exhausted and trying to learn a new, dense subject, you now know you mathematically require a 1/3 offline sleep cycle to re-index your mental Betty manifold.
When you walk through the woods and see a mushroom, you are looking at a highly optimized, decentralized topological navigator. You can see the underlying cost algebras and architectural keystones at play in literally everything.
It fundamentally changes the way you perceive the noise around you. You realize that beneath the chaos, beneath the muddy waters of daily life, there is an exquisitely precise structural logic.
It really does. But before we sign off, we want to leave you with one final provocative thought. Something to mull over that isn't explicitly written in these 21 files, but builds inextricably on everything we've discussed today. If the universe operates on these brutally strict ledgers, if it uses tension, compression, and incredibly precise quantum erasure just to remain stable, what happens to the entropy of all the alternate choices we didn't make today?
That is the ultimate question of human experience.
Think about the fork in the road you faced this morning or 10 years ago, the job you didn't take, the words you chose not to say out loud to someone you loved. Are those discarded human choices neatly, quietly folded into our own personal Betty manifolds by some benevolent mental fold operator? Are they truly gone, leaving no topological trace?
Where do they linger?
Exactly.
Yeah.
Or, because we hold on to them, because we remember them, are we carrying them around as a growing, unpruned quantum debt? Does the ghost of the life unlived constantly charge us a thermodynamic tax on our diversity face, pulling us closer to entropy saturation? It is something to deeply consider the next time you try to perfectly copy an old idea or find yourself wishing you could go back and take the other fork in the road. You might just be feeling the heavy compression of a universe that is far, far more wonderfully, terrifyingly complicated than we ever dared to imagine.